Greetings to you. We will start our module 2 today in the course of ICP-AES spectroscopy for pollution monitoring. In the last 1 hour, I have talked to you about the importance of spectroscopic methods and their relevance to the pollution control. So, I had also outlined to you the course programs, that the first part and second part, what would be the first module, second module, etc. And we had also discussed about the basics of spectroscopy. I had explained to you that even though it is not necessary to know about the atomic structure and other things, I have made it a part of the course, because many of the participants in this course are engineers as well as people coming from other disciplines. And because the atomic structure is the basis of all spectroscopic methods, I thought we will refresh your memory regarding the atomic and molecular structure. It will be basically of the level of graduation, and I think it will be a good revision for you. So, we will take about 4 to 5 lectures for this data for understanding of the atomic and molecular structure, and then we will move on to the interaction of electromagnetic radiation with matter. That is something to do with the basics of spectroscopy. So, we will continue our discussion now on atomic and molecular structure. This is module 2 and the title of the module 2 is atomic and molecular structure. So, what is an atom? So, do we know about atom since how long, and questions keep on being asked. Most of the physicists and chemists and every human being for that matter wants to know what are we made up of. In the Christian mythology, there is a concept of every human being is made from ashes to ashes and dust to dust. That is the basics of Christianism, and even in Hinduism we have known about the atoms since ancient times. Ancient Hindu scriptures recognized that matter is made up of tiny discrete particles, and they are known as paramanu and anu and kana. So, kana is an sort of a molecule or an aggregate of the smaller particles called as anu. So, we are all very familiar in India with anu. BARC, Bhabha Atomic Research Center is related to the generation of power and engaged in the utilization of nuclear energy, and that in Hindi translation it reads as Anu Shakti. So, Anu is part of the fundamental particle. So, Kana is the aggregate of smaller particle called as Anu, but it is not visible to the naked eye. And Anu of each substances are distinctive and capable of independent existence. That means, whatever you see around different objects, they are all made up of the basic structural unit called as Anu, which is having a separate existence. For example, the spectacle what I am wearing is made of glass. The Anu of glass is made of glass only, okay. And our body hair is made up of fundamental particle called Anu of the hair. A table will be made up of wood. Like that, distinct particles what you see around you are anus, and paramanu is the smallest discrete particle capable of independent existence, but it is not visible to the naked eye. That means, each anu of different materials what we see around us are made up of paramanus, and that is not visible to us as independent entity. So, it approximates to atom in a modern language. In scientific terms, we call it atoms. So, paramanu are the essential components of all things we see around us. So, now we know 3 fundamental particles known to Hinduism. One is paramanu, another is anu, and next is kana. And kana is the aggregate matter what you see around you as a distinctive object. Anu is the basic material which is capable of existence, and paramanu is capable of independent existence, but it is not visible to the naked eye. And paramanu is composed of different discrete fundamental particles, and that is not visible to our naked eye. So, the Hindu mythology routinely describes several warheads utilized in warfare, and the interplanetary travel as you hear around you in mythology. For example, Narada used to travel from one planet to another planet, and Bhuloka to Devaloka, Vaikuntha, Kailasa, like that. So, these interplanetary travels must be requiring some sort of aeroplanes. They were described as vimanas, and the power required for that kind of travel must have been a sort of nuclear power only. We can only guess about this at this time, because detailed descriptions of the design and other things are not available right now, or not accessible to human beings. And in the war, Mahabharata war and several Ramayana war, etc., there are several warheads described, and these are known as Shakti Astra, Brahmastra, Nagastra, Sarpastra, and so many other, Agni Astra. So many warheads have been described, and those things must also have been some sort of nuclear warheads capable of causing great disasters, which cannot but be from the nuclear forces. So, the idea is the concept of atoms and nuclear power is not new, but it was known to us, and so with that basics we lost it somewhere in between, and the modern era started, as you all know, in the Europe with Renaissance, and science was one of the earliest disciplines that received a fillip with the number of scientists working on different aspects of atomic structure, molecular structure, and things like that, chemistry, alchemy, several other medicine, several other aspects, and our current understanding of atomic structure is based on Dalton's theory. So, that is somewhere around 1802, the modern theory of atomic structure as we understand today is based on Dalton's theory of atomic structure. According to Dalton, all the matter is composed of tiny real particles called as atoms, which are indivisible, and cannot be created or destroyed. Two fundamental postulates. He said all particles are made up of atoms, and you cannot create an atom or you cannot destroy an atom. So, these two are the fundamental laws we all understand very easily. No logic is required, but the interpretation is ascribed to Dalton's theory. What he said is atoms of all structures are identical in nature, weight, size and other properties. That means, every material around you is made up of atoms which are identical in size, nature, weight, charge, etc. So, atoms of one pure substance and those of other pure substances like elements, what we call them, they differ in their weight and other characteristics. This also is pertaining to Dalton's theory, and atoms, another concept that he popularized is that the atoms combine in definite proportions, resulting in chemical compounds. That is, carbon will combine with oxygen, 2 molecules of oxygen to give you carbon dioxide, or it can combine with 1 molecule of oxygen to give you carbon monoxide. An oxygen atom can combine with another oxygen atom to give you oxygen molecule. Like that, different compounds, as we know all around us, are all composed of atoms combining in definite proportions. So, according to Dalton's atomic model, this is how it should look. For example, we have hydrogen here, and it has got a hydrogen atom is made up of 1 proton and 1 electron. Here we have, next is helium, and this helium atom is distinct from hydrogen and it has got 2 electrons. This concept of electrons did not come from Dalton, but there is a representation here, that is why I have not shown them in clear distinctively, but what I am trying to show you here is every atom is different from the other. This is hydrogen, helium, lithium. Our current understanding is it has got hydrogen has got 1 electron, helium has got 2, lithium has got 3, like that, but the atomic model basically is the fundamental particle of hydrogen, helium and lithium, etc. So, subsequent developments in science have led to the expansion of atomic theory. So, the basis for all this has come from the experimental data generated by a number of workers such as Michael Faraday, Rutherford, and then Millikan and Thomson, several other scientists engaged in the unraveling of the atomic structure over the years after John Dalton. So, what followed their discovery? Their work is the discovery of electrons, X-rays, radioactivity, nuclear reactions, and the discovery of subatomic particles. These things have led to our current understanding of the atomic structure. It is now widely recognized that atoms are composed of several types of subatomic particles, and some are capable of independent existence outside the atom, and some others are having an extremely short lifespan. So, such that we do not see them around us. Our human senses are not capable of realizing the events happening at microseconds or nanoseconds. So, some are having independent existence, some do not have as far as our sensory perception is concerned. So, among the stable particles, what we know? We know that electrons, protons and neutrons have independent existence. Okay. All atoms are composed of electrons, protons and neutrons, and they have independent existence. This every schoolboy knows. This is the result of the work of several scientists undertaken somewhere around 1800s and thereafter. Okay. So, then came Rutherfords model, that is somewhere around 1911. Imagine that we are talking of a research work of spanning about 100 years now. 1802 is Dalton's work and 1911 is Rutherfords model, and then what Rutherfords model is based upon the discovery of all electrons, protons, neutrons, etc. What he said is that the center of an atom, here you can see center of the atom is heavy and somewhat stable, and electrons are there around it circulating the protons or nucleus. And this is basically a simple model that states that the atom is a stable entity. Now, then came Bohr's model somewhere around 1913, and what he said is there are protons described here with positive charge, and there are neutrons described here which are shown in green color without any charge, and that is the heaviest part of the atom. It is at the center of the atomic structure, and around it there are electrons described by this blue pieces, blue balls that carry negative charge, and these charges, these electrons are going round and round the nucleus in fixed paths. The paths have been described here, and there may be more than one electron in a particular path, that is also understood, and then there are number of shells or energy levels at which all the electrons, each electron moves in a particular orbit. So, this is the Bohr's model, and these are called as electron orbit, the round ones, circles that are represented there, and then all other things we have already described. Okay, this I have taken from the Encyclopedia Britannica for easy reference. So what are the atomic particles? The atomic particles are electrons, protons, neutrons, etc. And the cathode rays impart negative charges to the objects in their paths, and they get deflected in applied electrostatic or magnetic field. So, J. Thomson showed that they cause ionization in gases. Okay. So, if you take cathode rays, pass them through a container having a gas molecule, you pass the cathode rays. Cathode rays means rays coming from a cathode, electromagnetic radiation coming from a cathode. If you pass them through a given gas molecule, gas container, they cause ionization in the gases. So, how do we know? Because if you put a photographic plate across the gas chamber, you will see that they get darkened. That means the rays are unable to pass through that and they get stopped, they create a dark shade. So, the cathode rays also yield X-rays against suitable target. You take cathode ray, okay, and then pass the cathode ray through on a metal piece, they will come here, hit it and bounce off, and the bounced off rays are not same as what you had started with, that is cathode rays, they give X-rays. So, what is X-rays? X-rays are cathode rays coming from the metal after bombarding the metal with the cathode rays. So, the wavelength of cathode rays should be smaller, larger than the X-rays, that is why they are called X-rays also. So, these particles were named as electrons. Okay. So, in 1897 Sir J. Thomson did that experiment, and then whatever rays were coming out, he called them as electrons. So, Thomson evaluated the ratio of the charge to mass, that is E by m. The electrons carry charge and it has got some mass for the electron from different sources, and showed that all of them to be identical. They have a charge of minus 4.8029 into 10 raised to 10 electrostatic units ESU, and an atomic mass of 0.0005486 atomic mass units. So, what is an atomic mass unit? It is one atomic mass unit is 1.6603 into 10 raised to minus 24 gram, that is approximately a hydrogen atom, the weight of one hydrogen atom, and each atomic mass of the electron is approximately 0.305486. So, the X-rays coming from the cathode rays, they were called electrons, and the electron charge and mass has been described. Now, what are the other particles, atomic particles people are familiar with? That is the proton. The protons are found to be identical with hydrogen atoms, from which single electrons have been removed. So, imagine this hydrogen atom, there is one electron here around it. If I remove this hydrogen atom, then what I have is a hydrogen atom without an electron, that is known as proton. So, just like electrons, protons are also present in all types of atomic species. That means they are universal in nature. Every material around us is composed of protons, and hence it is also considered as a fundamental particle whose mass is 1.00757 atomic mass units and charge is plus 4.8029. Okay. Now, we have described electron and proton. How we have described? We have described the origin of the electrons and protons, and we have described what is the mass of each electron and proton and what are the charges, electrostatic charges carried by electron and proton. Now, then there were other discoveries which led to the postulation of neutrons. So, bombardment of light elements such as beryllium, boron, etc. with alpha particles yields penetrating power radiation consisting of particles which are neutral in nature. So, the mass of each neutron is also approximately equal to the proton, and the reaction can be represented like this. That is, if I take beryllium atom having a charge of 4 units and mass of 9 units, okay, that is how the reaction is to be read. 4 beryllium 4 9 are treated with 2 He4, that is 2 charge of helium is 2, mass is 4. That means there are 2 protons and 2 neutrons, that makes it 4. Mass of the helium is 4 and mass of beryllium is 4 plus 5, that means it has 4 protons and 5 neutrons, and that if I hit it with helium of 2 and 4 mass and charge and mass, what I get is a carbon atom having 6 charge, positive charge and 12 mass, followed by 1 neutron which comes out of the system as a single entity separately. So, this entity does not have any charge, but it has got 1 unit mass, that is 1.00757 atomic mass units. So, this is neutron. So, these particles are known as neutrons, which have mass of 1.00757 AMU. Neutrons are unstable at outside the nuclei. That means, you let it out, let the neutron come out by the reaction with beryllium and helium. The neutron that comes out will not be having any separate existence, it will go and hit something and then combine with some other element. So, these neutrons do not have a separate existence. That means, you do not see them flying around, the neutrons are flying around you. So, over the years we have come across a number of unstable particles, and they have been their existence has been proved, and these include positron, neutrino, antineutrinos, mesons, etc. However, such particles are generated only under extreme conditions of pressure, temperature, and then magnetic fields, electric fields, like that, and most of them are chemical reactions, nuclear reactions. So, further, composite particles of hydrogen known as deuteron and doubly charged helium nucleus, that is alpha particles, are known to exist. For example, you take off the 2 electrons from helium, we have helium 2 plus. You look at this slide, now I have written here that alpha and helium 2 plus, and these are known to exist. So, our understanding that an atom is a simple system has been shattered. Okay. So, we do not know where these particles are in the located inside the atom, but we know that they are all there whenever there are extreme conditions of temperature, pressure and heat, electricity, nuclear reactions, and then nuclear fusions, fissions and all those things. They are all these particles are generated. These particles are known as positron, neutrino, antineutrinos, mesons, etc. And de Broglie, how are all these things, what are all these things doing inside an atom? So, that is a question. So, basically if an atom is electrically stable, that means all the positive charge in a atom must be balanced by all the negative charge somehow or the other. But if the electrons are if one nucleus is heavy and positive, electrons are around the nucleus going round and round, that means there will be attraction, and then subsequently all the electrons have to get stuck into along with they have to hit the nucleus and all charge should go. That means the whole universe should be neutral in nature. Unfortunately, it is not so. So, there are systems inside the atoms which are slightly different than what we know the rules of physics. So, the electrons do not get attracted to the nucleus, they maintain a steady respectable distance from the nucleus, and how these things are maintained is described by this Rutherford model, Bohr's model and all these things. What they say is, in general these things keep on revolving around it, and the force of attraction of the positive and negative charge is balanced by the force of repulsion generated by the centrifugal force and centripetal forces. So, in 1925 de Broglie, he advanced the theory that the electrons also possess wave properties such as reflection and diffraction. So, the wave properties means what? The electrons move in waves, not in straight line. So, even though they go around the nucleus in a specific fashion, regular circular orbits, they would be moving like this, round and round, but in a wave fashion. So, if the electron is moving in a wave fashion, it must also exhibit the properties of reflection and diffraction, because that they are the properties of all waves. So, this formed the theoretical basis of the extranuclear structure of the atoms. So, we will see what it is that extranuclear structure of the atom, what does it mean? It accommodates all kinds of particles inside the atom to maintain it in a neutral conditions, and the particle movement around the nucleus is what described by circular and wave nature of the electron movements. So, Röntgen, that was the scientist Röntgen, his experiments on the bombardment of a target with cathode rays, they yielded a highly penetrating radiation of wavelengths which he called X-rays. Now, the X-rays are the cathode rays which are hitting a metal target and then coming off the metal target. So, these rays are called as X-rays. So, such radiation is due to the energy released when an inner electron is released and other electrons drop into the vacant slots. That means, when X-rays hit, when X-rays are coming out, the electron from a higher orbit falls to lower orbit, and then the energy difference comes out as X-ray. So, the conservation of mass and energy is always maintained, which is the fundamental rule of physics. So, that also is a same another interpretation of Dalton's theory, that is, you cannot create energy nor destroy energy. You cannot create a atom nor destroy an atom, but you can change them around. So, a positively charged nucleus, which is therefore, the atomic structure current theory is, we believe that the atom consists of two parts, namely a positively charged nucleus which is a very small in size, approximately 10⁻⁻12 centimeter, okay, and it is comparatively heavy with respect to the electrons. So, around the nucleus there is an extranuclear arrangement of electrons loosely arranged around the nucleus in a space of about 10⁻⁸ centimeter and diffuse in character. It is not very well defined. So, for example, you can imagine the size, the nuclear size is 10⁻⁻12, okay, and the electrons, the size of the area of the electron moving around it is approximately 10⁻⁸ centimeter. That means, there is a difference of about 10⁴. The space occupied by the electron is 10,000 times more than the space occupied by the nucleus. There is an order of 4 difference, no, 10⁻⁻12 and 10 raised to minus 8. So, 10 raised to minus 4, that is, this is 4 times 10,000 times bigger the area or volume occupied by the electrons compared to the nucleus. So, the nucleus governs the physical properties of the element, and the extranuclear structure is considered as responsible for the chemical properties of the element. That is, the electrons around it are the particles responsible for the chemical reactions, and that is our understanding of the electroatomic structure. Now, the alpha particle is used as a bombarding particle, and the neutron is a product of the radioactive decay. Since these have been proved earlier, unstable particles and composite particles, which I mentioned as mesons and other things, they do not have any role in the ultimate composition of the matter. Even though they are there, the positrons, mesons, neutrinos, etc., even though they are there, they do not have any role in the day to day composition of the matter. So, the modern atomic theory in recent years has been, apart from these things, it has to include wave nature of the electrons also, and it is a highly mathematical, it has got a highly mathematical character, and several physical and chemical characteristics can be derived from our current understanding of the atomic structure. We will continue our discussion in the next session. Thank you.